the rocket is just above the horizon 365 miles away. No, that there is not the rocket. The rocket is up here. The Falcon Heavy is up here somewhere, because this is all burning and fire. Maybe that is the Falcon Heavy there. I don't know. Right? Now, that's 3 seconds. And look at the difference. It's already very obviously well above the horizon, several degrees. And 1 minute now. Now, so 7 seconds later, and it's there. Like, this is probably about 4 degrees above the horizon. So 134, right? So leave it play till 141. 26.8 kilometers. And that's in an arc that's moving away. That arc is moving away from them off out to the east. And it's an arc. So it's not going to be straight up in the air. So that's easily 2.6 degrees.
Hello. In this video, I'm going to import some Flight Club tracking data into GeoGebra, specifically the recent Falcon Heavy mission. Photographers and YouTubers like WheresWally can use this data to successfully track the trajectories of rockets after they launch, and that's for any location they happen to be at. The data I'm using is for an observer situated on Myrtle Beach in South Carolina, and I'm interested in the altitude and range information for each second of the flight. And hopefully, using some geometry, I'll be able to see what that data looks like for that observer in terms of angular sizes, visible and hidden amounts. So let me explain what I've got going on here. This is our observer, who is 10 meters above sea level at Myrtle Beach. This is the horizon. This vertical line, this represents the combined altitude of Falcon Heavy, split into two parts showing what is and what isn't visible for this time. The surface distance from the observer for this time is shown here in green, and that's this point here. Values can be input directly using these boxes, or can be adjusted with these sliders, while data for specific times can be shown using these presets, or with this slider. Now obviously, refraction plays a role in how much there is to see above the horizon, and this is the coefficient value that I've chosen. And I got that from Walter Bisland's website. That's this value here. Rather than trying to measure the path of each bending light ray to determine what the observer sees, we can alter the radius of those light rays, effectively straightening them out, which makes the geometry much simpler. Doing this means that we also have to change the radius of the Earth by an equivalent amount. That's to keep it equal. This is the coefficient for 7/6R, and if there was no atmosphere, the light rays will have an infinite radius, and that's just another way of saying that they don't bend. If we stop the clock on Cinema Control's excellent Supercut video 90 seconds after launch, we can see that there's no sign of Falcon Heavy in this picture. So what does that look like? And as you can see, it's not far away from crossing the horizon line, and its altitude is over 20 kilometers high. And the question WheresWally and everybody else who are asking flat earthers is, where's it hiding? We first get a glimpse of the rocket around 93 to 94 seconds in. And now you can see there's about 68 meters popping out.
So 7 seconds later, and it's there. Like, this is probably about 4 degrees.
4 degrees. More like 0.4 degrees.
Look at this. This is a black swan. It's nonsense. It's not going to be the same equal distance between Myrtle Beach and Cape Canaveral. It just won't be. If it's moving due east, it's going to change because of the angle between Myrtle Beach and that rocket going due east from Cape Canaveral. You know what I mean? It's going to end up being the hypotenuse of a triangle. Do you know what I mean? Whereas the adjacent would be, let's just say, of a right triangle, whereas the adjacent would be between Myrtle Beach and Cape Canaveral, and then the opposite would be between Cape Canaveral and where the rocket is at 1 minute 33 or 34 seconds. Total flat plane. So it's total fabrication, total rubbish. So it's total nonsense, proving the Earth is absolutely flat. This is a black swan. But the point is that I don't know.
So the question remains for Brian's logic, Flatzoid, Bev and pals. Why weren't we able to see the rocket until its angular size reached about 2.1 degrees? Is there anything else, I wonder, that's 2.1 degrees that we're unable to see? How about a London bus from 120 meters away? So this mission had a nighttime launch, and on a flat plane, it's impossible to see its light when it's 25 kilometers high, but not when it's 20. So anyway, that's going to be the end of this video. And as usual, I'll leave a link in the description for the script. Thanks very much for watching, and I'll catch you later.